So very good afternoon one and all. I'm going to start the session on the subject of your circuit theory or network analysis. So welcome you all in this session. So we're learning the chapter of the two-port network. Already we have studied the basic concept related to the two-port network, the parameters, and the introductory part related to the two-port network. So today we will continue this session, the numerical on the basis of the T and the pi network. Why we are telling it this is a T and the pi, just the connection, or you can say the what you can say the which is the circuitry which is looking like a T, the circuitry which is looking like a pi is nothing but the T and the pi, and in that particular network we are going to simplify the numerical on the basis of the especially the two port. Secondly is nothing but the transformation of the two-port network. Transformation, already we are aware, we are having a various parameters in the two-port. That is nothing but the Z, your H, your ABCD, your the Y parameter. Many parameters are there. So in that we are shuffling, we are transferring from the one parameter to the another. Just take the example. If the circuitry is already mentioning the Z parameter, you can convert into the Y, you can convert into the transmission, that is nothing but the ABCD. You can convert in the hybrid, that is nothing but the H. You can convert into the inverse hybrid, that is nothing but the G. Likewise, or if you are having in the Y, so you can convert it to the Z and other thing. If you are the circuitry in the form of your ABCD, you can convert in other thing. You are having the circuit of H, you can convert in any other. So likewise, the what you can say the transformation among the parameters that we will observe in the two-port network. The third, we will continue in this session, today's session, that is nothing but interconnection of the two-port network. How I can connect my network, okay, in the form of the two port, that is the input port as well as the output port. By considering these two ports, how I can connect my network, whether I can connect in the what we can say, a series, the parallel, whatever. So that the types, various types, we will see various connection we will see, and how we can simplify the numerical on the basis of that. Today we will see that session. So we will start, we will begin with the, you can say, the numerical on the T and the pi section. That is the representation of the connection will be either the T or the pi. So start with the first one. All of you just draw the circuit. Find the Z parameter for the following network. So see here, by looking the circuitry, you can identify easily. This is nothing but you are the looking like a T section, okay? But it's not clearly mentioned in many of the numerical. They may mention and they may not mention. Here not mentioned, no need to worry. Simply we can simplify. We are having our two choices. One is nothing but with the help of the mesh analysis, you can simplify the network. With the help of the nodal also, you can simplify the network, okay? So there are various things, a way by which you can simply or directly you can transform from the one parameter to the other parameter. So by looking this one, so this is looking like a T. If you observe this one, that is nothing but the Z1, Z2, and the Z3. Okay, and the current which is flowing at the input side, input port is nothing but the I1, and the current which is at the output port is nothing but the I2, and the voltage drop across the each port, that is nothing but the input, and the output is nothing but V1 and the V2. So how we can simplify such a network? Okay, how the current is flowing. See here the direction of the current, even though not mentioned in the numerical, always remember you can assume likewise. Okay. So see here the from the input I1 is going, from the output I2 is going, and both are meeting at this node at the junction, and they are coming down. That is that both the current which is flowing in the Z3 is nothing but the I1 along with your the I2. The combination of the both the current is nothing but your the I1 plus I2 which is flowing in the Z3. So likewise by using the KVL, the loop equation, you can write yourself, that is the voltage as well as the current equation you can write. So here in the Z parameter, we are interested in the writing the equation of the V1 as well as the V2. How I can write the V is equals to IZ. I'm not writing here the R just because of the Z is Z representation is here. So always be remember with the help of the Ohm's law, V is equals to IZ again, plus of V is equals to IZ. So this form is nothing but the I, and this is nothing but the Z, IZ. Again this IZ. So see here V1, V is equals to IZ is nothing but in the first case, V is equals to I1, Z1. So this is finished. Now come towards plus. Again, the V1 is equals to IZ. What is I? I is nothing but I1 plus I2 in one of the bracket, and Z is nothing but the Z3. So likewise, if you are going to simplify getting the I1 at the one side and an I2 at the one side, so you will be able to find the current which is flowing and the I1 current which is flowing, the impedances are nothing but you are the Z1 and Z3, whereas I2 is flowing in the Z2. So likewise, you can separate out the equation, final equation, whatever you will get, that is nothing but the equation number one. Similarly, if you are looking from the output port or output side, if I am looking from this side, V2 side, so how the V2 is equals to V is equals to IZ, again the formula by Ohm's law. So V is equals to I2 into Z2. You can take this Z2, I2 into Z2, and plus again the V2 is equals to your this combination I1 plus I2 into Z3. Um, so now go for the, just by comparing the equation 1 and 2, that is nothing but the V1 along with your the V2. If I'm going to compare these two equations, so how I can write, how I can represent my Z parameters in terms of the equation that is mentioned. Okay, so what is that equation? We know very well in the two-port network, we are having the four terminals, that is nothing but Z11, 12, 21, and the 22. What we are having? Z11, Z12, Z22, and Z21. Likewise, how we can represent in the T section? So my Z11 will be equals to the 1 and 3. So which is the one? This section. This is 1 and this is 3. So this is the combination of these two is nothing but my Z11. Okay. Similarly, with the 1, 2 is nothing but you are the directly Z3. This one, 2. This 1, 2 is nothing but the Z3. And 2, 1 is also the Z3. Okay. 2, 1 is also, because if you are looking from here, the 1, 2. If you are looking from here, then the 2, 1. So likewise. And the 2, 2 is nothing but you are the Z2 and the Z3. So see here, if I am looking from this side, 1, 1. If I am looking from this side, Z2, Z11, Z22. Now the middle part will be the 2, 1 and the 1, 2. Okay. 2, 1 and the 1. Likewise, you can simplify the numericals. Now go for the next. In this case, we are having the value. In the previous case, just we have tried to simplify. If I am having the impedance, any kind of impedances without any the value, how I can simplify with the help of the KVL that we have seen. But here, the values are mentioned. The what we can say, the notations are also mentioned. That is nothing but the A, B, C, D. Likewise, the voltage and the currents are there. How they are flowing, and in this way, by applying the KVL to the loop, okay, how I can simplify, how I can find my all the four terminals, that is nothing but Z11, 12, Z21 and Z22, okay, in the Z parameter. So note on this numerical, find the Z parameter for the network shown below. So 5 kilo ohm, 3 kilo ohm and 12 kilo ohm. So these are the impedances which are in the kilo ohms. Okay, so this is nothing but my Z1, this is nothing but my Z2, this middle part is nothing but my Z3. The current is I1 at the input, at the output is I2. V1 at the input as well as the V2 at the output side. By using the KVL, oh, again same with the help of the Ohm's law, V is equals to IR form. So V is equals to IZ for the first portion, again plus of IZ for the middle portion. Because if I'm looking from the input side, definitely I should bother about my the impedances or the resistances which are across in front of that from where I'm looking. Okay, so here 5K will affect as well as the 12K. So see here in the 12K, two currents are flowing, the I1 as well as along with the I2. That's why the 12K is I1 plus of I2, whereas the 5K is only the I1 is flowing. Now segregate these two, that is nothing but the current I1 is flowing how many resistors, and the I2 is flowing how many resistors. So final equation is nothing but the I1. Similarly, go for the V2, just because you just look from the output side. If you are observing from the output side, what will be the effect of that? So again, the V is equals to IR plus again the V is equals to IR. So here the 3K I2 is going to flow, and in the 12K, so the Z2 as well as the Z3, or you can say in short, the current I1 is flowing, okay, because here I1 plus I2, here I2, okay. So you just segregate this one which current is flowing and make a equation. So in this way you can compare the equation number 1 and 2, that is in the form of your V1 and the V2. Now already in the previous slide we have observed what is my Z11, that is nothing but the combination of your the if you're talking about the impedance Z1 and the Z3, whereas if you're talking about the resistance R1 plus R3 like this. in this way, you can find easily that is 12 plus 5 is nothing but the 17, because I'm looking from the input port, that is a Z11 I'm interested here, whereas at the output I'm interested Z22, and in the middle part that is a Z12 and the 21. Getting? So now the Z11 is the combination of the 5K and the 12K is the 17, 12 and the 21. Okay, 12 and the 21 are nothing but the middle part, that is the 12K, whereas the last part, so Z22 is nothing but the combination of 12K plus the 3K. 12K plus 3K is nothing but the 15K. So likewise, you can simplify the numerical. Now go for the next. In the T, see here in this case, the T is clearly mentioned. In the previous, it's not mentioned, but here it clearly mentioned in the T network. Okay, the figure is shown here. The Z1 is a 2 angle of 0 degree, whereas Z2 is the 5 angle of minus 90 degrees, Z3 is a 3 angle of 90 degrees. So here the impedances are presenting in the form of the polar, and you need to find out the Z parameters. Okay, so see here the I1 and I2 is V1, V2, but in the form of the polar. So 2 angle of 0, 5 angle of minus 90, whereas the 3 angle of 90 degrees. So here the Z1, here the Z2 middle part is nothing but minus Z3. Same method you can apply directly here by using the KVL to the, and you may write the loop equations in the form of your the V1 and the V2. Okay. We remember why you're going to simplify the Z parameters. We are interested in the voltages. Okay, so V1 and the V2 equations. If you are going to simplify the Y parameters, that is in the parallel circuitry, so at that time you just go for the equation in terms of the currents. So here I'm again applying the Ohm's law and I'm writing in terms of the polars. So V1 is equals to, see here, so 2 angle of 0 degree, the I1 is flowing in that, and the middle case is nothing but 3 angle of 90 degree, 2 currents are flowing, I1 and I2. And go it here, I1 and I1 is flowing the 2, that is a 2 angle of 0 degree as well as 3 angle of 90 degrees. So just make it at one side and do the I2 at the other side and make the equation number 1 for this one. Go the observation from the output side. So if you're looking from here, again the 5 minus 90 degree, whereas the 3 angle of 90 degree, both the current is flowing I1 and I2. So make it separate out, just keep at which current I1 is flowing in which impedances and I2 is flowing in which impedances. So here to compare the equation 1 and 2. So if you're going to add the Z1, if I'm going to simplify or find out the Z11, so definitely I'm interested at the input side. So 2 angle of 0 degree plus of 3 angle of 90 degrees, so you will be able to find. So directly in the polar form, we are aware that the addition in the polar form is not at all directly possible. You need to convert that polar into the rectangular, then you to add the things. Okay, so convert this polar form with the help of the shift and the POL and the REC form in the calculator. So if you are going to convert this 2 angle of 0 degree and the 3 angle of 90 degree, you will be able to find both the side rectangular will be there, and then add the real term as well as the imaginary, you will be able to find 2 plus 3 of J, or 2 plus J3, doesn't matter, 2 plus 3 J or 2 plus J3. Okay, even though you are going to stop here, doesn't matter, or other in other way, if you are going to convert once again the rectangular into the polar, so you can find the answer will be 3.60 and the angle will be you are the 56 degree in the Ohm. Similarly, the middle part is nothing but 3 angle of 90 degrees, that will be your Z1 and the 21, so both will be the same, and the last part is nothing but the Z22. So in the Z22 you can find easily, that is the combination, which are the combination 5 angle of you are the minus 90 degree, whereas as well as 3 angle of 90 degree, both are in polar. So just convert the individually this 5 angle minus 90 degree into the rectangular, again 3 angle of 90 degree into the rectangular. After getting into the rectangular, again add the real term as well as the imaginary, you will be able to find that is a 2 angle of minus 90 degrees. So this way you can simplify the numerical. Now switch toward the next numerical. So what is that? Find the open circuit parameters of the two-port network. Okay, shown below. So see here, open circuit and the short circuit. The name itself already indicating, and already in the theoretical part we have explained. The Z parameters are also known as the open circuited, whereas where what we can say, the short circuited parameters are nothing but your the admittance parameter, that is nothing but the Y parameter. So this circuitry is in the form of the inductor as well as the capacitor, and we are aware this is looking like your the T. If you are going to observe, this is looking like a T, and this is the Z parameter just because of the open circuited. So V1, V2, I1, I2, and the J40, J80, and the middle is nothing but the capacitor, which is the minus J160. So again, by assuming the open circuit of the output terminal by using the Z parameters, so see here how I can write my equation. So V1 is equals to V is equals to IZ. V is equals to IZ. So see here in this case, V1 is equals to I is nothing but my I1 current. So I1 into J of, see here, the 40 minus of, you can say 160, 40 minus 160, 40 minus 160. So you can take directly. So now how I can find my Z11? Again, we know very well, Z apostrophe S of V and I. So what is my V? V is also 1. What is my I? That is also 1. So the Z is nothing but the ratio of the voltage and the current. Basic formula here, the Z impedance. Z is equals to V by I. If I am writing 1, 1, 1, 2, 2, 1 or 2, 2, whatever it is, that will be the apostrophe of V and I, representation of the voltage as well as the current. So see here 1, 1 is there, both have will be 1, 1 whenever the current I2 will be equals to 0. Similarly, if I am interested to 1, so 2 and the 1, then again the I2 is equals to 0 in the second time when the input port is to be open. So that time what will be the case? So here in this case, if I am looking from the input side, so I1 is current is flowing J in bracket 40 minus 160. And similarly in the second case here, middle part, Z21 and the Z12. Z21 and Z12 are nothing but the middle part. So that is nothing but minus J160. Directly you can write Z21 and Z12 is equals to, that is nothing but minus J of 160. Similarly go for the last, that is a Z22. How you can write, you are observing from this side, okay, you are observing from this side, that is nothing but I2 into J of 80 minus of 80 minus of 160, you can take that one, okay. And in this way you can write, finally you can write the 40 minus of 160, what is going on, then the directly this term is the in the imaginary, whereas other is again the 80 minus of 160. So like this you can write the parameter finally whatever you are getting. Z11 is a minus J of 120, Z12 is a J of minus J of 160, 21 is also minus J of 160, and the finally is nothing but you are the Z22, that is a again the 80 minus J of 80, all are in ohm, just because the unit of impedance is ohm. Now come towards the pi, okay, and in the pi we know very well, the pi is nothing but the just like with the parallel circuitry, and we are trying to simplify that numerical on the basis of you are the short circuited in the Y parameters, because short circuiting is happening in the Y parameters. Okay, if you observe, it's looking like pi, so here the YA, here the YB and the YC, YA, YB, YC. This is looking like you are the pi. So current I1 is at the input, current I2 is at the output, V1 and the V2. And see here, again, further two currents are there which are going to flow from the in the parallel section. Okay, so here at this particular moment, from the positive to the up to the this node is the my I1, whereas at this node that is I2, but the other current which is flowing from the A to the bottom and the C from the bottom is nothing but my the what we can say this one, this two, middle is the three, this one is the 4, and last is nothing but the 5. Okay, see here. So going here, so going here, and so coming back. So like this 3, 4, 5. You can assume any, but you should be careful while you are going to give the direction. Okay, and the notation, that is nothing but A, C, A, B, A, B, C, and D. Just like any notation you can give. Again, apply the KCL whenever there is a node. Definitely be remembered for the KCL. You should move towards the KCL just because of the nodes. If you are having the loop, go for the KVL. So here the nodes are there. That is nothing but the node A as well as the node C is too important here. So by using the KCL, I is equals to I. Okay, so which current is there? I at the input is nothing but my I1, and this I1 which is going towards the A. And from this particular A point, all of you pay attention here at this node A. Two currents are outgoing currents. One is nothing but the I3 and other is nothing but the I4. I3 and I4. Okay. And we are aware incoming current is equals to outgoing current, or incoming minus of outgoing is equals to 0, the summation of all. Okay. So see here that these two are outgoing. That's why the I3 plus of I4. Whereas if you are writing in terms of the admittance form and the voltages, so all of you pay attention here. My I1 is equals to, so which voltage potential is here? V1 across the YA, V1 across the YA plus again at this particular moment, that is nothing but the A. So here the V1 minus of V2 V1 minus of V2. Why I am saying the V2? Because my other, that is nothing but the VB, this section. So which is where the other voltage is nothing but my V2. Because the current are many, but the potentials are the input and the output, and we have taken as only two. That is the input potential is a V1 and output potential is a V2. So see here at this moment, this is the V1 potential and here is the V2 potential. So definitely, if I'm writing the current I1, so that will be difference. I is equals to V by R, but here the admittance is there, so no need to take the in the denominator. Directly you can write in the numerator, just because 1 by Z is nothing but the Y. 1 by Z is nothing but the Y. I is equals to V by R. Okay, so no need to take 1 by R, just because we are talking about the admittance, that is nothing but the Y. So here I1 is equals to V by, okay, so V of, where is that man? See, I1 is equals to V1 minus V2 of this VB, this section. Now, finally, which potentials are, that is V1 and the V2. This is totally vice versa case of your the impedance Z parameters, okay? So see here, in previous case, we were interested in the current to write out okay, how much amount of a current is flowing in the impedances, whereas which potential is across that admittance we are interested in this case. So segregate, separate out. So I1 is equals to, the V1 is focusing on the two admittance, that is the VA as well as the VB, whereas your V2 is focusing on the one that is nothing but the YB. Just say, see here the direction of the current, which will be, if I'm looking from this side, so definitely the current direction will be opposite. That's why I have taken here minus. So that's the final equation is nothing but the I1, equation number 1. Now again applying the KCL at the node, at a node C. Where is my node C? Node C is here. I'm focusing on this node C. So I2 will be the combination of, see here, the at the particular section I2, this is incoming, that is nothing but the I4 is incoming, whereas I5 is outgoing. So I5 minus I4, outgoing minus incoming, I5 minus incoming, okay, outgoing minus incoming. So likewise, I2 will be my I5 minus I4. Now just write the equation I2 is equals to, if I'm looking from this side, that is a V2 across the VC, YC. Okay. Now again, the I2 is equals to two potential with what you can say, you can take as either V2 minus V1 or V1 minus of, and finally V1 minus minus will become as a plus. So you can take either the V2 minus V1 or the V1 minus of V2, but along with your the minus term, along with your the minus term. So be careful at this moment while you are going to observe from, whether you are observing from input, whether you are observing from the output. This is too important. So like this, you can write finally the equation of this one. You can compare that one. Okay. After the comparison, you can write again here the four terminals, that is nothing but y11, y12, y21, and y22. So while you are observing y11, you are interested at the input. While you are observing for writing for the terminal y22, you are observing at the output. Whereas y21 and 12, you are interested at the middle section. So what is my y11? Y11 is nothing but YA and the YBC here, YA and the YB. Whereas Y22 is nothing but YC and YC and Y. And what is the middle? Middle is nothing but only the, in the both the cases, if you observe, so you will be able to find that is nothing but the YB is middle. YB is middle for the 1, 2 as well as for the 2, 1. So in this way, you can write the expression for all. So this is in the form of your the values are given. Instead of this is the YA, this is the YB, this is the YC, YABC. YA is the 5 kilo ohm and the YB is the 1 kilo ohm. YC is a 2 kilo ohm. So values are given and you need to simplify this numerical, which is in the pi section, and by using the Y parameters or the short circuited parameters, you need to find out the all the values, that is nothing but the YA, YB, YC, along with your the equivalent circuitry like your the terminal in the form of the terminal y11, 12, 21, and 2. So see here YA is nothing but your the YA. So YA is nothing but your the 1 by of the 5K. So see here 1 by this one. YB is nothing but a 1 by 1 again, and the YC is nothing but the 1 by 2. So likewise, you can find easily YA, YB, and YC because Y is equals to 1 by Z. Y is equals to 1 by Z. How we got all these things? 1 by Z, and 1 by Z1, 1 by Z2, 1 by Z3. Likewise, you can find easily. And later on, you just substitute all the value in the form. Y11 is a YB, YB. Y12 and 21 is nothing but here the middle part is nothing but here the Y, what you can say, which things are middle, that is nothing but the 1K. And the last is Y22, which is nothing but the YB and YC. In this way, you can simplify this section, this by section. Now go for the next, again the Z parameters. So here inverse form is given. See here the Z1, Z2, Z3, I1 and I2 and V1, V2. Here 1, 1, 1, 2, 1, 2 and 2, 1 both are the same. We have studied. 1, 1 and 2, 2 are different input, output, and this is the middle section. So 1, 1 is a 10 ohm. This middle section is a 5 ohm, whereas 2, 2 is nothing but 20 ohm. The last section, that is the output section. Find out the equivalent T network. What is the question? The terminal values are given, and you need to find out the T section. This is the inverse numerical likelihood of whatever you are simplifying the previous case. So by applying the KVL to the mesh 1, by applying the KVL to the mesh 2. Why we are saying? Because this is the T network. So at the beginning, just draw the T network and mention the values Z1, Z2, Z3. Mention all the notation I1, I2, A1, B2. And then apply the mesh just because of the impedance. So by applying the mesh 1 at this moment and mesh 2 at this side, so you will be able to find applying the KVL to the mesh 1, B is equals to IZ plus again B is equals to IZ here. Again B is equals to IZ, B is equals to IZ. So here will be combination I1, I2. Here will be the directly V1 is equals to IZ, that is Z2, I2. Because this I2 is from here, okay. From this node, there will be a division of a current. That's why we are considering this I2. If you are looking from the mesh 2 at this moment, so here will be Z2, Z3 will be add, and the I2 is flowing. And if you are observing across, that is nothing but the Z2, I1, because I1 is flowing in that, and across the V2. So in this way, compare the equation number 1 and 2, you will be able to find 1, 1 is nothing but the Z1 plus Z2, that is nothing but the 10, and 1, 2 and 2, 1 are nothing but the middle part Z2, that is nothing but the 5 ohm. And the last is Z22, which you are going to observe from the output, that is nothing but the Z2 and Z20. So in this way, you can simplify easily what is the value of your the Z1, what is the value of your the Z2, what is the value of your the Z3, like this. So this is again the pi, the values are given, inverse values are given by 1, 0.09 mho, and by 1, 2 and 2, 1 is nothing but minus 0.05 mho, and the last Y22 is nothing but 0.07 mho. Find the value of the RA, RB, RC. Maybe it will be written in the form of your the what you can say the other value also. That is also possible. So at that time you can find either in terms of the impedance of the resistance. So here they are interested in the RA, RB, RC. So what is my RA, RB, and RC? Here is RA, here is the RB, and the last is nothing but RC. I1 and I2 are flowing, V1 and V2 are across that one. Okay, so here the I1 is equals to just because of the pi section, just because of the parallel section, the nodal analysis is applicable. So that's why we are interested in the KCL by applying the KCL at the node 1, by applying the KCL at node 2. So where is my node 1 and 2? At this moment, here is my node 1, here is my node 2. Okay, so I is equals to V by R, I is equals to again the V by R. So what is my at the input side? I is equals to V1 by R, R is nothing but the RL. Similarly, I is equals to V by R at this potential V1 minus of V2 divided by RB. So just equate, take V1 at one side, V2 at the other side, final equation will be equation number 1. Again, applying the KCL at the node 2 at this particular, if you're looking from the output side at this section, again the I is equals to V by R, so here will be the V2 by RC because that is across. And again, if I'm looking from the output, definitely I should give the priority to that particular voltage. So V2 minus V1. In this case, V1 minus V2. Why V1? I am giving the priority to the input side because I am observing from the input side. If V2 minus V1, see here the vice versa case. But if I am at the output side, so definitely I should give the priority to my that particular potential. So V2 minus V1. Here is a V1 minus V2. Likewise, equate two equations, equation number 1 and 2, and complete that equations. And write down in terms of the terminals, that is y11 is equals to. If z is there, directly you can take, but y is there, y is equals to 1 by z. So 1 by RA plus 1 by RB. So that is nothing but written here 0.09. 1 by RA plus 1 by RB is 0.09. By 1, 2 and by 2, 1 is nothing but middle section, that is RB. So write that RB will be twice, either from the input observation and from the output. That's why so minus of 1 by RB, minus of 1 by RB. So minus of 0.05, again minus of 0.05. Getting these two. So Y22 is nothing but 1 by RB plus 1 by RC. That is nothing but 0.07 mho. So in this way, you can simplify the numerical. You can write the values of your the RA, RB as well as RC. What is my RA? What is my RB? And what is my RC? Is by adding all these things. Now go for the transformation. In the transformation, we are just transferring from the Z to all other parameters, Y to all other parameters, ABCD to all, and likewise. So how we can simplify? First of all, we remember how we can write the equation. So this is the open circuited is nothing but the Z, short circuited is a Y, transmission is the ABCD, inverse is the A dash, B dash, C dash, D dash, hybrid is the H, and inverse hybrid is the G. So here already we have discussed about how if I'm the Z, if I'm talking about the Z, definitely I'm interested in the equation V1, V2. If I'm talking about the Y, I'm interested in I1 and I2. If I'm talking about the transmission ABCD, so V1 and the I1. If I'm talking about the inverse, V2 and the I2. Hybrid is nothing but again the V1 and the I2. Likewise, we should remember okay, this is the interrelationship or the transformation. So this del is nothing but the del may be the Z, del may be the Y, del may be the ABCD, del may be the H, or del may be the G. So likewise, the X is nothing but the indicating the parameters, that is the Y, Z, ABCD, H, and likewise the hybrid and all. So how we can find the del of so-and-so parameter? That is a 1, 1, 2, 2. 1, 1, 2, 2 minus of 1, 2, and 2, 1. We remember. So this is the expression of where the Z parameter. If you are going to convert into the Y, so my Z11 will be equals to ZY22 divided by del of Y. If I'm interested in Z12, so that will be equals to minus Y12 divided by del of Y. But if I want my Z parameter in terms of the, what we can say, the transmission, that is nothing but the ABCD. So Z11 is equals to A by C. Z12 is equals to del T by C. Okay, what is that? T is nothing but again here the, what we can say, the AD minus of BC likewise. Okay. Similarly, the Z21 is nothing but 1 by C, Z22 is nothing but D by C likewise. So here Z can be converted into the Y, into the, what you can say, the transmission, inverse transmission, habit, and the G. This okay. If this is the Y, so how I can convert my Y parameter into the Z? The Y will be the same one, but Y we can convert into the this one, this one, this one. So all this sheet is too important for the interrelationship or for what we can say connection or the transformation from the one parameter to the another parameter. Once you simplify any one of by taking the reference of any one, you can convert easily in the other. But we remember the del part. The del part is nothing but you are the all the parameters, that is nothing but you are the Z11, Z22 minus of Z12 and Z21. If you're interested in the Y, so del of Y is nothing but the Y11, Y22 minus Y12 and Y21. If I'm interested in the ABCD, so del of T is nothing but you are the, that maybe you are the AD minus of the BC likewise, or H11, H22 minus H21 and H12 likewise, okay. G11, G22, G12 and G21 likewise. So this sheet is too important while you are going to simplify. So here again, same sheet, only the reflection in the, if I'm writing the Z11 in the form of your the Y, how I can represent. So Y22 del of Y, this case, all the parameter 1, 1, 1, 1, 2, 2, 1, 2, 2, and how I can represent that Z in the form of your the Y, that is nothing but 1, 1, 1, 2, 2, 1, 2, 2, and how I can write my del Y, that is del Y is equals to Y11, Y22 minus Y12, 2. So likewise, see here in the Z parameters in the form of the ABCD. So AD minus BC divided by C is nothing but the 1, 2 and the 2, 1. And how I can write my 1, 1 and the 2, 2, that is A by C and the D by C likewise. So same thing if you want the Z parameters in the form of the hybrid. Hybrid is Mason and the unknown is Z parameters. That time also del H divided by H22. So in this way you can simplify and